Welcome back, welcome back. I found the notes for this last little part. Okay, so I didn't want to, I wanted to make sure I did this right. Okay, so how you do this math, first we write down the energy it took for the first step, and then we write down the energy we take for the second step, and we subtract them. But if you have two negatives, what do they make? A positive. So this is really negative 394 plus 396. And what is that answer? 2. So our heat is 2. Okay, now our last little idea. Thermodynamics. The law of, we talked about, and in fact, Dresden did, the law of conservation of mass, which means that mass cannot be created or destroyed. But also, energy cannot be created or destroyed. It can only change from one form to another. So that's why it's called the law of conservation. Neither mass nor energy can be created or destroyed. They can only change from one form to another. This is also called the first law of thermodynamics. So the second one, or entropy, is that things go from order to disorder naturally. So they only go from disorder to order if acted upon by an outside force. That's the second law. Well, this is the first one. And it's really just a different way of saying the law of conservation. The energy of the universe is constant. The energy of the universe is constant. So the order is becoming more disordered, but the energy is staying the same. Okay, can you kind of imagine all that? Yes? All right. Here's another example for order to disorder. Okay? Imagine I have, and I used to do this, but I don't do this example anymore. I don't like doing this demo anymore. Imagine I have some perfume up here, and right now all the perfume molecules are nice and ordered, and they are in the container. If I open the perfume, will all the molecules stay in the container, or after a while will I be able to smell the perfume? I'll be able to smell it, won't I? And in fact, the suggested demo is you get some really loud perfume, and then you have the kids raise their hand as they start to be able to smell it. That order quickly spreads out and becomes disorder. The order of the molecules in the bottle, I don't have to do anything. I don't have to scoop up the molecules and throw some over here or throw some over there. All by themselves, based on entropy, they are going to become more disordered. And then they're going to go from being in the bottle to spreading out throughout the room. Does that make sense to you? You can sort of imagine the entropy now? Okay. All right. So that's the notes. And I'm going to end the video. Like, share, subscribe. Science is great.